All right, we are live. Hello, everyone. Welcome to the fifth episode of Observability Unplugged. Super excited to have you all here. Yes, we have been having these consistently over the past few weeks, bringing in different perspectives and new guests in each episode. My name is Kunal, working as a DevRel engineer at Randoli, and I'm joined by Rajat, founder and CTO at Randoli. And as I mentioned, right, we've been doing these podcast series throughout the entire past months, and the aim is for us to cover a certain topic in the observability and the AI ecosystem because there is just so much happening around all the time, and our aim is to educate all of you on one particular topic in each podcast, right? So consider this as a informal fireside chat, right? And today I'm very excited to have Manoj on the chat with us today. And we are going to talk
Yes.
a little bit about AIOps, right? And because you know, I think in today's times, if we don't include AI in any conversation, it sort of feels as incomplete, right? AI is like being included in every aspect of whether we talk about in the operations, that's what we're going to talk about. But in each and every area, we have been talking about AI. And something that we are going to discuss today is how AI is changing the incident response lifecycle, how AI can be integrated into the ops field, the IT operations field. That is how it's called as AI ops, right? So we're going to discuss a bunch of different topics related to this, but just a bit of context for everyone. I met Manoj at a recent meetup, and he was giving a talk around the similar topic on AI ops, and I really liked the perspective that he brought into this particular topic. So I thought, Manoj, can you please cover all of that, but in a virtual setting, like this podcast? So Manoj, thank you so much for taking out your time today. Would love to know more about you. Would you like to introduce yourself and tell us everyone a bit about what are you doing these days?
Yeah, thanks, Kunal. And it's really nice to hear a feedback, right? That you really like those session and the way the perspective which I put in for AIOps. And it's rarely happens that right within a week we became friend and then I'm with you here to present. But yeah, things happen, especially when the mindset and the vibe actually connects. Anyway, yeah. My name is Manoj, as Kunal already suggested. So I have around 20 plus year of experience, no development, all about operations, testing, stress, verifications, validation, and all. That's what I have done throughout my career. So I'm fortunate to see those old way of doing things and the new way of doing things, and then trying to keep track with that. But yeah, I started my career with IBM long back, 2004. The whole database middleware we talked about there, and then jumped to cloud only in 2014 or 15 around that, and that's where the whole perspective got changed from a self-hosted old legacy system to new microservice based cloud architecture. And that's where the whole journey started, from old way of working to actually start seeing the system in a totally modern or a new way. From that onwards, I think around the last 10 or 11 years, it's all about DevOps, observability, improving reliability, making sure that system remain reliable, system is performing well. We are meeting our SLAs and SLIs, all that from 8 or 9 years. And I continue to evolve. And the way tech is evolving around that observability, it's just whole time gets spent just to keep pace with that, just keep catching up on those new things on daily basis, and still feel like, oh, I'm still missing something, I'm still have a lot other things to cover.
Oh, I definitely agree. I mean, especially for the last one, right? There is a so much happening every day. Because I've been following a lot of specifically for Open Telemetry. I try to follow the recent announcements, right? There's so much discussion happening. There's so much new changes coming up each week that sometimes it's just harder to keep track. What's the new tool going to do, and what it is improving. But that was sort of one of me and Rajat's aim to start this podcast series to try to connect those latest announcements to people and trying to bring out these new topics, right? So I'm very glad that you could join us today, right? And I think we are going to have a pretty interesting discussion because both of you have been there, both of you have been at the ground level, and now you both of you are leading teams, right, of engineers. So I think this is something pretty interesting. So just a bit of marketing stuff for folks who are just joining right now. If you're joining us from LinkedIn and YouTube, because we are streaming on both the platforms, I would love to know where you're joining from. So you can just write a hey in the chat, and feel free to ask any questions that you have during the entire session. We'd love to take any questions or any suggestions related to the topic that we are talking about. And because this is sort of part of the CNCF community event, so please be respectful to everyone, right? One thing just I'd suggest, if you're joining from LinkedIn though, there is a bit of lag in LinkedIn chat, so we are not able to view it. So I suggest everyone, if you want to chat with us, you could please join the YouTube live stream, because we are streaming there as well. It's just a bit easier to ask your question there. So I've just send the link of the YouTube live stream here as well, so you all can join that too. But
Kunal,
let's
we have
start.
the Twitter live stream as well.
Yes, Rajat, we are streaming on Twitter as
You
well.
want to put the link there as well, so I can post it on Twitter.
Sure, definitely. I'll just grab the link for that as well. It's harder to keep track when you're
I
streaming
know
on
that's
multiple
right.
platforms. Alrighty, here you.
Thank you.
Right.
Sure.
Yeah.
So here's the link to Twitter too, right here. Alrighty. So let's start, right? Without wasting time. So let's set the context. So as I mentioned, right, this whole topic of AI ops, and including AI in the operations field, and a subset of that is AI driven observability, which we are going to cover that as well. But we've been hearing a lot of discussions about this, and but I want to start from the past and try to connect the dots, because as I mentioned, right, you both have been at the ground level and now you're leading teams. So going to the past, if you think of how you used to deal with incidents and how you used to deal with those production fires, right? Where did you feel the gap is, and the gap was at that particular time, in the way we used to do traditional monitoring, then we shifted to modern observability, and now if we talk about the typical incident response cycle, where did you feel the gap is? And bec- why have this whole discussion of AI ops started in the first place, right? So Manoj, do you want to take that first?
Yeah, I mean, in very generic term, right? There is a generational gap, a big generational gap from the way we were doing monitoring in the past and monitoring doing today, and the basic reason is the whole architecture, the whole development processes has been changed a lot. I mean, from the time, right, in 20 years back when we used to develop, it used to be an year or 2 year release, completely quality focused things. We never thought of speed. We never thought of innovations. What is the preferred way today, that speed and innovation should take the first step. But yeah, and past, I mean, most of the application get I will say solution get deployed on maybe one big server, maybe two, or maybe max three big servers. We are not going beyond that. I mean, everything was on the same server. Your DB server, your caching, your app server, your web server, your code, most of the things are running onto a single or two, maybe high-end actually servers. So what that gives you, because the code is of a good quality, because the quality focused development, everything is on the single platform or a single VM. So moving parts are really less. I mean, everything is in the single system, right? And most of the time, the whole monitoring thing used to happen through logs. I don't think so. If you go 20 years back and say, okay, you need to monitor, it actually means monitoring logs. We never thought about traces. We never thought about metrics. Everything is in log. And most of the developers used to put everything in the log itself. Any error, any exception, any stack trace, any usage, everything is in the logs. So that's what used to happen 20 years back. But with the cloud era, right, it's all about speed, it's all about scale, it's all about maintainability. So everything get broken down to small or smallest sizes possible, right? People start writing small microservices. Maybe around 8-10 people team is just handling one microservice. They don't care about anything else. They are just have one microservice, and they have actually exposed some of the endpoints or some of the things which people other can consume. Now with this, and of course the cloud era, right? So we don't know on which VM we are running. I mean, we don't have a control on the underneath hardware at all. I mean, we are just doing a containerization everywhere. Now with this, right, a simple, I will say, a heavy application on two server has gone into 200 containers, all networking come into picture. And one request which used to run on a single process had started running into 20, 30, 50 processes. So the whole complexity of our architecture has gone so deep down that logs are just not good enough, right? So you need something more than the logs. I mean, if I have something, some request going on to 10 or 20 different microservices, see how SRE will see 20 different blocks of different 20 different applications. Every application has its own way of logging. Their format is totally different. They may not be even correlated, right? It's a nightmare. It's become a nightmare for a SRE to actually correlate or find out a single call and the whole path of it, right? So that's the complexity which has grown, and that's where the whole monitoring, which is just a log based, we are getting into a whole observability where you have to observe the whole path at all. There is a very interesting analogy. I mean, I just want to give an example. I'm sure I'm not taking much time. I know, Rajit, you have to also respond on that. But very nice analogy to compare the monitoring 20 years back and the observability today, right? In a very simple terms, you have a road, and that road is actually very accident prone road, right? uh, it was accident prone 20 years back also, it is accident prone today also, but 20 years back it was like 4 or 5 heavy trucks was just walking on the same path with the same speed, everything is like thing, and they will never met an accident because they will always go in the same direction at the same speed. But today you have bikes, you have cars, you have trucks, you have buses, and it's going in all directions, coming back, going down, and all that stuff. And then actually there is high chances of meeting an accident, right? Somewhere something will happen. So 20 years back, monitoring means only putting an ambulance on that road. If something happens, rarely, which used to rare level, I have an ambulance put in there, which will actually uh, take the people. I mean, whoever is the victim of an accident, take the people to the hospital and get it corrected. But what happened today? Putting an ambulance when there are 50 accidents happening together, it just doesn't help you out. Either you put so many SRE engineers or you start doing something proactive. Something proactive means you put a speed governor in the system, you put a speed detector in the system, you put a traffic police to challan who is not doing the lane driving, somebody is driving. So all these are proactive steps which you actually do to make sure that accident doesn't happen. And that's what is happening now. I mean, we are not doing the order. We have to put something in place when application is running. We are to observe, and we have to put those things in place so that you can actually avoid accident instead of doing an accident and then taking an action, right? On top of that, instead of that, do the avoid action and take that action. So I feel that analogy maybe help people understand what was the application 20 years back, 5 trucks running, and now there are hundreds of trucks with different speed, different techniques, different everything is running together in a different direction. Chances of accident is high. So you need better proactive steps to actually make sure accident doesn't happen.
That actually makes sense, and I love that analogy. Right, you broke down into pretty simple one, and I think it's safe to say that I mean we say that things have kind of become simple with these processes, but things have become a bit more complex as well at the same time, right? But Rajat, to you, right? What gaps have you noticed as Manoj was mentioning? Because what I feel is this whole discussion of reducing the mean time to response, it's not new, right? It's been there, right, previously as well, and now with the new set of techniques that we have, there are new set of challenges. So what are the typical gaps you noticed in incident response, and how you used to do how you used to take out those production fires when you were when you dealt into those particular areas?
Yeah. First of all, great analogy, Manoj, and then it's also a bit of a blast from the past. We talked about, you had a handful of servers, and now we have lots of microservices, and the complexity has gone out of the roof, right? And yeah, so I think he really explained a lot of that stuff. And that, just to dig into that analogy, I think that's a great way to kind of explain, because it's not practical to kind of keep putting out fires. So you want to think more proactively. And at the same time, no matter what we do, accidents will happen and fires will pop out. So we'll have to figure out how to put them out quicker as well. But you have to tackle from both fronts. Otherwise, SRE teams are getting overwhelmed. So going back into that, like the gaps, I think it is the complexity of the applications, like Manoj mentioned. We went from monoliths to microservices, and there are so many different failure modes. I can talk from an application architecture points, right? Like before, it was simply a call from one method to another, but now it's a remote call. It's either an HTTP call or an RPC call that happens when you move something that runs in the same process into two different processes. Automatically, there are multiple failure modes that happens, right? Like the other process may be available, may not be available. It might be a temporary issue, it might be a permanent issue. When I say permanent, like last more than a couple seconds or minutes, depending on the context of the application. That's more than enough for something to miss the SLO, or for that to have issues that propagates that fault all the way up its call chain and cause an outage, right? Yeah, the other process, you have to do retry, you have to think about circuit breaking. There's all kinds of other things that you have to now think about as an application developer, and people make mistakes, or there are bugs in libraries, and then all of this can cause all kinds of failure modes that we didn't used to see in a monolith, because everything happened there. Same with the logs that Manoj talked about, right? Before, it's easy to correlate. Now, if they don't have a correlation ID, hard to trace it across, right? And sometimes some people miss. There's also going to be blind spots. If you profile in the past, remember we used to profile with J profile and stuff like that in the Java world, right? And now, how can you profile? Because you have a lot. So now there's techniques with continuous profiling and other stuff like. But before, we used to have, like, we could just connect the J profile. I remember we were looking at it. It's practically impossible to do that across like 20, 30 microservices in that call chain, right? And and I'm hearing that like there are tracers with thousands of spans, tracers that takes a long time, and you're getting gigabytes and gigabytes of logs, gigabytes of spans, a couple minutes, and it's mind blowing to hear some of these numbers. So it's humanly impossible, like Manoj said, for a bunch of SREs to keep track of all of this. It's a whack-a-mole situation. So you definitely need some help to take more proactive action, and then when the fires pop out, to respond to them quicker. So those are the kind of like the gaps that I see. With the sort of like the modern approach, to building distributed systems.
That's really some interesting points, Rajat. Because for someone like me, hearing about this, one question that directly, right now popped into my mind was, I'm sorry, why are we thinking of AI ops now? Why not a few years back? If we had these many challenges, if we had these many gaps, and if engineers knew that, hey, we actually need something, so why are we having this discussion today? I would love to hear this from you, because was it like, were we building the fundamentals, were we building that ground for us to now being at a good position so that we can implement AI right now? What was happening there? So Manoj, do you want to take this one first? What do you think?
Yeah, sure. I mean, I won't say AI is new. I think Tom is totally changed. Of course, the techniques has also changed. But when it comes to intelligence, just as a what you call English word, we used to have analytics in the past, right? The predictive analytics and all that database related concepts where we used to do some kind of thing. I will say it's a very smaller version of AI. That also there was a mathematical formula. There is a mathematical things which get created. And of course, there's a major complexity. I mean, when you add more layers, more things, then it become an AI because you have a lot more variables added to it. But yeah, why AI now? Why AI ops now? I think the one line answer is standardization. It's very important, right? If you see in the past, most of the observability platform have their own way of capturing the data. They have their own agents. They have their own naming conventions to the metrics. And I have seen myself somebody using system, somebody using host, somebody using computer, somebody is using something. I mean, for the same VM machine, I mean, there are 10 different namings which are being used by different systems. Now, when you like to train any AI model on this different data structures, I don't think so. AI can do a good job, right? It's very difficult to actually say, okay, system is same as a host, or a system is same as VM, or a system is same as machine. No, that's different altogether. Now, with the advent of open telemetry, right? I think just 3 years back, the foundation has been set where you say you have to call this metric ABC only, be it from vendor X or be it from vendor Y or be it from vendor Z. You have to give us the same naming conventions. Now, when those conventions came, right, you now AI can actually make sense. If data is coming from a vendor X or a vendor Y, they are calling the metric same, right? It's get easier now to actually correlate. Your logs may be from, let's say, log4j, or maybe it's just something else. Your metric, even it's coming from Prometheus, it's aligning with the OpenTelemetry standard. Yes, it's easier. So as they say, right, whatever you check in, you will get the same thing out. It's like garbage in, garbage and out kind of stuff, right? And if you get a good quality data to an AI, you will get a good response and good accuracy also. So I think that garbage has gone now, and we have a standard data which is a quality data and across signals, and it's just not related to only logs metrics, log metric traces, and maybe future profiling and other signals whatever being covered by OpenTelemetry. It will be a standard definition. Now, when you have got a quality data, AI can be trained, right? And it's get easier for an AI to actually now analyze and get the insight out of it. So as I said, with the foundation is the standardization of data, standardization of a signal, and I think OpenTelemetry is doing a really great job to bring that standardization. And that's how the whole AIOps is now booming, because there is a standard data underneath which every vendor can work upon.
And now we are sort of thinking what to do with that standard data now that we have the data. How
Yes.
can we get more clarity, right? That's a separate question that we are asking with ourselves. Rajat, do you have any points to share here?
Yeah, a couple of points. I think first of all, I do agree with Manoj that standardization has helped and it's going to help. I also think that observability has become more mainstream right now. People are aware of it. I think in the past, like 10 years ago, or maybe even sometimes 5 years ago, observability was an afterthought, right? You scramble to put in logs when there's a production issue, right?
Yeah.
I remember in the past, like when something happens, oh, you know what? Let's add more logs and hope we can reproduce the issue, or it happens again, right? So that has been the mentality. But right now, people are like, some organizations don't go to prod like that. You know, they will fail you from going to prod if you don't have, have you got all your metrics up and running? Have you have you followed the logging standards? Have you done this? Have you done that? So there is some thought and care being given into observability. So that has been there. And I think for a while, people have been trying to automate things and trying to figure out different techniques to get to root cause analysis. So people have been trying in the past. So like Manoj said, it's not a new thing. People have been thinking about this because I've been hearing this term for the last 5 to 6 years, if not more. People are thinking about trying to do, but I think with AI becoming a little bit more mainstream and making it more accessible, I think it has again given some life to the whole AI ops conversation. I think it's not that people didn't want to do it before, but I think like a whole bunch of things came together, and with AI becoming more accessible, it is making it's making it a little bit more easier to now to implement. But just to conclude my thoughts, I think what Manoj said is very important. I think no amount of AI automation can succeed if the underlying quality of the data is bad. Like bad data, bad signals will translate into garbage output, right? So it's important for people are thinking about that. I think the quality of the signals to be there, because that directly translates to the outcomes, whether you're doing an impact analysis or a root cause analysis. it really boils down to the underlying data. So that's very important.
I
Because,
just want to augment Rajit on that, right? Observability shifting left is a really, really great thing if it start happening, right? Uh, Observability or monitoring was always the afterthought, and that's really, really true. I mean, I do remember in the past, if there is any production issue, right, we used to get a utility, and we were told run this utility in your production to collect some metric and reproduce that issue, and then collect those debug logs and all, because
yes.
that used to happen. And observability getting shifted to left to a development cycle, actually giving what you need if something happens, that has to be built in your code. So if you need such kind of a data, if something happens, you don't need to run a special utility for that. You should have that as part of your observability that is getting captured already in your backend or a monitoring system, right? That's what really important. And I still see no, I mean, rarely any development team is actually thinking about observability at the time of development, right? And that's a really great point. I mean, observability has to shift to the left. It has to come to a mainstream application development. There has to be a section about what you need. If you're writing a function, do you need something to be observed so that this function can be monitored on the production side, how it's behaving? So that question developers should ask them whenever they are developing a feature, and make that signal added. And of course, as I said, OpenTelemetry gives you all those APIs, all of the standard way of actually instrumenting the code.
That's a very valid point, Manoj. Thanks for sharing, and thanks for sharing your perspective as well, Rajat. I think this whole topic of shift left observability, right? This is something that I also heard a lot of people talk about at KubeCon India, which I went to last year. People were talking about this, and yes, there is still a gap here, as you mentioned. Yes, we need to pay more attention to this particular area as well, right? And but I think the discussion has started, and couple of I see a couple of open source tools trying to work in this particular domain as well, apart from OpenTelemetry, trying to see, okay, if you are developing your application, how can you mirror those staging environment or production calls so that you can test your features with the data you have, so that when you are into production, you don't have to, follow that whole cycle or the loop again, right? So there are a couple of interesting things happening in that area as well. But thanks for sharing your perspective. Now that we've introduced AIOps, right, and now that we know, all right, this is something that now is the need. What I've seen is, right, and something that I also covered in one of my talks in the meetup was, uh, one thing is clear, that we have all the data now, right? And it's, if you are using OpenTelemetry, or if you have some kind of a observability pipeline in place which is enhancing the quality of the data, you have quality data, right? Yet there are still no clear answers when an incident hits. Yet we are still talking about reducing mean time to response, right? So what I've realized is teams are starting to see this, that they don't need more visualizations or more data. We already have the data, we have the alerts, right? But there needs to be more context in what we have, right? There needs to be some process so that all of this becomes smarter. I'm sorry. And I think AI is here to do that. AI is here to fill that gap, in my opinion. And we'll discuss about the different stages of the AI ops cycle and how AI implements it. But I'm curious to know, before we start discussing that, do you folks remember your first, when you saw the first impact of AI in what you have been doing till now, and how did that change when AI was into the picture? And was there any specific incident, or was there any specific pattern where you thought, okay, we need to bring this kind of intelligence to the entire flow? Um, anyone can start on this. Manoj, would you like to take this?
Yes. I mean, this is a very interesting question, actually. We continue to do a lot of experiments to fix a lot of issues in our existing systems, uh, where the real impact is. And again, as I said, right, there are a lot of scope. Of course, AI promises us a lot of things, right? You talk about that visualization is no more, and I really agree. Static visualization has no life now. It's out of the shelf completely. You have to come up with an interactive way of doing some things. If even required visualization is required, it has to be interactive. You can actually do dynamic queries, patterns, and other things, that you can ask questions and then actually give you some kind of a visualization on the fly. So that those kind of things AI do promise. But of course, we will discussing this maybe as we talk about AI of cycle. But your question, right? What is the first impact I have seen, and I love to talk about that a lot. The alert fatigue thing. Uh, I mean, it's a disaster, right? When you have static threshold, right? When you put something like if CPU is going above 90%, give me an alert, and then an alert happens at night 2 o'clock, and my SRE person come up and say, okay, application has no impact. I mean, the whole night is wasted, right? I mean, there is no impact to the customer. What this alert is all about? And one of the major change, I mean, which AI brought and made our life easy to start with the anomaly detection. And that's something which does not require so much of intelligence or so much of things which an RCA finding and other features of AI or other promises of AI needs. Anomaly detection is really simple. I mean, of course, AI is doing it in the past. Analytics was doing it. Pattern recognition is not an AI task, right? We used to do it in a different way altogether in the past too. But yeah, giving your alerts a threshold which is based upon your anomaly detection and not on a static thing is something which has the first thing which we started using in there. So if you have something which always remain between 80 and 90%, and most of the time, I don't need an alarm at a 90% or it is goes to a 91%, right? Because it's usual, it's normal, 90% is normal. I don't need it. I should be happy that my resources are being consumed fully. I'm not wasting my resources at a 90% of the time, always, and customer has no impact. So yeah, that was one of the use case I always recall. It's I think couple of years back. This is something we shifted from the older way of creating alerts, where we used to somehow figure it out what should be the threshold based upon our internal testing, performance testing, and all that stuff. We just left it out. We told, okay, AI, go ahead and check my historical data, see what pattern you are seeing. In the night, if it's 90%, I'm okay with 90% also, if there's no customer impact. Or and if in the daytime it's 50 or 40, I'm okay with that too, if it's there's no impact. So find out your threshold based upon the historical data. I'm not going to tell you at all. So that's the anomaly detection, and the alerts reduced a lot of fake alerts for us, and started giving us something better, something which is really useful. So I think that's the use case I always talk about, and that's where I always say AIOps, your AI adoption should start. You should start looking at the pattern first before you actually start looking at the data and start looking at the specifics of that data.
That's pretty interesting, and love that point about, because one of the starting stages of an incident is an alert. Everything starts from an alert, right?
Yes.
In the typical incident response workflow, and we're going to definitely cover that particular topic, and we're going to dive deep into that aspect as well. But thank you so much for sharing. Rajat, I mean, what about you? We have built an AI agent recently, right? But is this something that you is there any past experience, is there a past incident that you noticed, oh, I mean, I need this, I mean, this is a turning point that we need in the typical flow?
Yeah, that's a, it's a great question, and I liked what Manoj said as well. I want to acknowledge that. I think alert fatigue is a huge problem for most people, and it's great if if the alerts can be um, adjusted based on what's normal, because what's normal varies from organization to organization, application to application, system to system, right? So it has to be something that's that can be tunable. We used to do it by hand. Now you can use AI agents. So going back to the original question, I think I think we all agree that looking at dashboards is not the right kind of approach, because unless you really understand what's going on, you're very experienced, you might be able to glean something from it. Even then, there's a chance that you will miss something, right? Like 2 years ago, we were working with a customer that had had this particular production issue for 2 weeks. Nobody could figure out We were actually at the time we were sorry 3 years ago we were doing some consulting for them. They couldn't figure out what was going on until we finally found out what was going on. Myself and someone else. But the problem was there was no lack of dashboards. There was dashboards. There was logs. There was traces. Sorry, they didn't have traces, but they had logs and metrics. But the problem was the inability to correlate between those signals. And I wouldn't even call the metrics and logs are actual signals. They're raw telemetry, and you need to come up with some signals, right? And then you have to be able to correlate with those signals to pinpoint. And I think some of those incidents actually really um, drove me to build what we built today. Those kind of incidents, and they were like I said, experienced people, not due to lack of dashboards or like telemetry available, but it is the fact that it took some time. It's also production systems, not much you could do. It was hard to reproduce, but putting two and two together was the difficult task. Like, how do you correlate these things? And I think that's what drove me to kind of build what we have built today. And it's arguably a very hard task, right? So that's kind of like some of those things that shaped. And then when my view of this whole thing, and then when we were able to put two and two together in some of our experiments, that really excited me. So that's why we went down that path of RC and impact analysis and stuff like that. We're also experimenting with exactly what Manoj mentioned. It's a bit of a hard of a problem, but it'll be great because, like both of you mentioned, alerts is the first line of defense. And it's too much. Like, people talk about alert fatigue a lot, and we can dive into that a little bit deeper. So yeah, those are the two things that I would say caught my attention based on past experience, and that shaped my view of what AIOps can do or should do. Yeah.
Love that point. That's very relatable, and I definitely agree with all of those points, right? And this is something that I covered in my recent talk, and I think a lot of people at the meetup, and I think Manoj as well related to that, right? Right. We have the data, but yet still there are some gaps, there are some unclear answers, right? And one of the things that is what AI is here to solve, right? How can we get more context? So I think this is a very clear point, right? That's why we need something like that's why this whole discussion of AI ops started in the first place, right? One of the doubts people have in mind whenever we talk about AI is, oh, it's going to replace me, it's going to replace my job, but it's not something that's going to replace humans. It's about helping teams move from raw signals, as you mentioned, Rajat, from raw telemetry, I'm sorry, to signals, right? Contextual signals, and get those relevant answers faster with a bit more context, a bit more of that out of the box correlation, and a bit more intelligence, right? That's what AI ops is here to solve. So let's do one thing, right? Right now, let's walk through the key stages of a typical incident response workflow, right? Everything starts from an alert. I've broken these down into 4 key stages because if we break it down to multiple stages, there are a lot of tiny stages that we can cover, right? But given the time of the episode, I've broken down these into 4 main stages. We'll start from an alert, we'll go on to correlation and root cause analysis, we'll then talk about remediation, and then lastly, to cover it all off, we can talk about the feedback loop, like which we all talk about, right? So let's start with alerting, right? This is the very first thing we experience as an incident, as I mentioned, is an alert. Everything starts from an alert. And one of the things which I've noticed in the discussion platforms and people are discussing about AI ops is the conversation often starts after teams hit some kind of a breaking point, and that's usually the signal overload we talk about and the alert fatigue, right? So the problem isn't that we don't have the alerts. As we mentioned, we have the alerts now, but the problem is we have too many of them. They are too noisy, right? You have got like 50 alerts firing, but only one or two matter, as you pointed rightly, Manoj, in a particular incident. So I want to tackle this question head on, right? What can be done to reduce the noise that we have with the alerts, right? How can we make them less noisy, a bit more actionable? And is this something that AI or including intelligence can really help with, right? So Manoj, why don't you take this forward first?
Yeah, I mean, alert fatigue is surely a problem, and the problem from both the sides. If you take it as a business side or you take it as from the SRE perspective, if there is something happening and the customer is really impacted and you don't see any alert, I mean that's a bigger problem. That's a big gap. That's not an alert fatigue, but that's a big gap. But if you are seeing a customer impact and your SRE team has thousands of alert coming and they don't know which alert is actually causing that issue, I mean, that's even challenging for the SRE guy, right? Out finding out of that 100 alerts, okay, these two or three are actually the real reason of the customer problem. Finding that two, three is really, really difficult. So from business perspective, it reduces. I mean, your response time increase, your resolution time increase because you have to now look at the thousands of alerts together. And let's say even if your team, though I see I don't think the teams can do that, but let's say you even have a lot of people who can do 100 alert analysis in a minute. What if that alert does not have anything? I mean, it just say response time slow. It doesn't talk about anything else. There is no context. I mean, a lot slow for what? Is it an API? Which port? And which service? Is it a DB? Or what is all about, right? It doesn't say anything. And that's blow up SRE's mind. If you go to an SRE, say, my response time is slow, can you fix it? I mean, it's like how to fix. I mean, I don't know anything. I have thousands of microservices running, and you just say my response time is slow. I don't know which service, which TB, where the all things are coming. So yes, you have a business loss because you have thousands of alert, and figuring it out which alert is impacting is time consuming. Once even you figure it out, those two, three alerts which is being impacting, there is no context into that alert, there is no data into that alert, that again further delays, right? The whole SRE stuff. So yeah, the first entry point to AIOps has to be a really effective and optimizing your alert strategy. Simple as that. I mean, you do not want to alert too much. At the same time, you do not want to miss anything. I mean, you don't want to keep any gap. So that customer is impacted, but you are not even know about it, right? Customer is reporting, and that's where the whole the SLA SLO concept come into picture, where we say don't monitor everything. Monitor what is real customer impact is. If your customer impact is response time, then monitor the response time. If your customer impact is error rate, response error rate. Don't monitor CPU, don't monitor memory, don't monitor my disk. What is actually an impact? Delay, whatever your response time is. Define those factors which actually really impact and start monitoring that and start alerting only on top of that. And then, of course, you add context to it. I mean, you have to have alerting strategy in a way that somebody is actually adding those context into that alert based upon all the resources underneath impacting. Even if it's a CPU high, that is a underneath what you call symptom. That's not the direct impact, right? That's something at the resource level. So your response time is slow is the alert, but then you have port name, port CPU usage, port memory usage, container readiness probe, startup probe. All that is actually a context to this uh, response flow, right? You know response flow is because of this port, and you add all the port related data, port related signal to that alert. So that gives you a contextual or context-rich alert to the SRE. So I think that's one of the entry point. I mean, from the alerting perspective, how you redesign your alert from the older way to actually a newer way, where you can make use of better strategy and reduce your alert fatigue for your SREs.
That's a very interesting point, right? You know, try to first figure out, try to align those signals, those alerts to business goals, right? Defining your SLIs, SLOs, and SLAs, and to alert on those rather than just alerting on simple data, right? CPU alert, memory alert, these single alerts, right? Rajat, any points you have to share in this one?
Yeah, I mean, just to amplify what Manoj was saying, I absolutely agree with Manoj about, I think one key way to reduce alert fatigue is alerting on the right data, and having the confidence that they actually reflect your business goals. to his point, like just because CPU memory is high doesn't necessarily mean your customers are impacted. And at the same token, just because your CPU memory are low doesn't necessarily mean your customers are happy either, because they still could be facing slowdowns, and you're getting this sort of the wrong signal, right? So I'm also a big believer in measuring what your customers are seeing, or measuring what your partners are seeing, because that is a better indication of your system health than anything else. Obviously, you have to keep an eye on system related things, like CPU and memory sort of across the board, because eventually the resource pressure can push back on, and cause issues, right? Like they'll create back pressure, or outages of your underlying infrastructure, etc. But I think way before you get to that point, your customers may be experiencing issues. So what Manoj said is very important. You have to measure what the customers are saying. So that's number one. The other thing about alerts is that, I think Manoj also talked about this. If you're getting a whole bunch of alerts and you not being able to figure out which one I should be prioritized, it's actually that's an issue that we are trying to tackle right now. If you're getting 10 critical alerts, which one should I be looking at first? Because solving one might actually, reduce the entire pressure in the system. So if I focus on the wrong one, then that means I am taking longer to resolve the real issue, and that increases my MTTR. So understanding which one to look at first is very critical, and that's where I think AI can help to say, you know what, you got 10 critical alerts, but you look at this one first, right? The second one I think Manoj mentioned was context. If I get like random alerts that says, oh, CPU increased, memory increased, or something went out of memory, because alerts, in my opinion, more often than not, highlighting signals, highlighting symptoms of a system, especially if your alerts are not necessarily tied to, how do I say, customer facing issues. Even then, though, if I get an alert says this exceeded, my P95 SLO, it's still a bit of a symptom, and you have some ways to get to the root cause, right? So alerts by nature are more or less tied to the symptoms. So at least try to figure out, better symptoms that can help you get the root cause quicker. But also understand that you have still a couple steps to get to the root cause. Eventually, I think we will all figure out how to get as close as possible to the root cause with the alerts. But I think it really depends on a lot of factors. But that's something that hopefully we can achieve. Yeah, so those are the three things that I could see, on the alert front, that can cause issues, and some potential resolutions that I mentioned. Yeah.
Really great points. Yeah, I definitely agree. And one of the points that you mentioned, right? If let's say you are still able to filter out, okay, these are the 10 alerts that gets fired up. You have, those are related to your business goals, but AI can help us figure out, okay, out of those 10, which one to prioritize, right? Which one to prioritize, and taking a step ahead can give you that essential context which we talked about, right? Love that point. So let's talk about the next. So once that alert is fired, the real challenge begins, which is figuring it out why happened, right? And the contextual information that we get from the previous step can help to reduce the area, but still there is an area to be explored, right? And because we talked about correlating different events here, correlating different signals. Under pressure, correlation can be a bit shallow and can be misleading sometimes and can increase time, right? Because sometimes two things might look connected just because they happen at the same time, but they might not be related, right? I remember, Manoj, this is one of the points you also covered in your talk. So, where do you think AI can generally help here, right? Especially in separating what can be just a coincidence and what's actually causing that particular issue, right? So, Manoj, do you want to take this?
Yeah, so I'll just first want to augment Rajit, the point, right? Uh, Correlation is important, but most of the time direct correlation doesn't help. I mean, of course, you have a correlation based upon let's say an attribute name, or on a timestamp, right? The one you say that because something happened at the same time does not mean that they are actually causing each other, right? And of course, you might have a direct correlation because there is a pod ID or there is a container ID which is actually same. So you are saying, okay, that may be a problem together. Most of the time, or I will say 80 to 90% of the time, the alert, right, what Rajesh said, right, alert may not be closer to your RCA. Maybe 10-20% your alert may be closer, but 80 to 90% it's not closer, because most of the production issues that does not happen because of the one variable. There are 10 different variables which are coming together to create a situation that problem happens, right? And there is an interesting use case in there. Of course, many of the microservice, what you call, people may not agree, but in reality, many a time our microservices use same database. I know that that's not the pattern in microservice, but yeah, when you are migrating from monolithic to microservice, right, it's very hard to actually separate out your database. Generally, what you do is let's use the same database as of now. And I've seen use cases when a different call on one microservice and a particular call on second microservice and a particular call on third microservice, when they fire together, there is a database deadlock exist. But there's the situation that has to come together. There's an update from one, select from other, delete from the third one, and they are actually fired together in such a order that deadlock happens. Okay. Now your monitoring alert will clearly say deadlock happened, and that's caused the issue. And when the DBA will go, it's really difficult to figure it out, because you will see from one microservice, some SQLs are getting executed. They will not create an deadlock at all. You go to second microservice, something is happening there. You don't see that the deadlock is happening. It's very difficult to figure that out, because there are 3 or 4 different variables, and there's a time, and there's a transaction happening from the user side which actually coexisted at the same time to create that deadlock. So yeah, so lot of the time in production, right, when you're running at scale, when there are a lot of load on your application, such situation happens when multiple processes comes together to actually create an issue. And direct correlation doesn't sort it out, because here there are different containers involved, there are different pods involved, there are different services involved. Sometimes the service one you see there's a timeout and there's a rollback. The second time it may be a second service which got rolled back first. Third time the third service get rolled back. I mean, all three are rolling back, but they are not causing deadlock standalone. They are causing deadlock with the two other services together at the same time. So yeah, so how to go closer to the RCA now? That's the question. I will not directly jump on to start finding the causation. I think there is a way to start is to actually have AI giving us answer to our questions, right? Answer to our question. What is happening in microservice A when microservice B actually rolled out? Can my AI figure that out, right? Something of that sort. Any RCA cannot be found with a one query. First of all, you have to have a step by step 8, 10, 20 steps to be executed to get reached to RCA, right? So my system or my AI ops is capable of at least answering simple queries first. Yes, if they are doing that, answering those queries accurately, then you go move to the next step of causation. What is causing what? So older way we used to do with the timestamp based log. Everything was the timestamp. You check the timestamp here, and you go there and check the timestamp in and try to correlate there. But yeah, so once alert is fired, it's not a normal alert. Of course, it's not something which is close to the RCA. The next step is to actually figure it out how to correlate this alert. If you have, it has a context altogether, and does my AI is able to make a knowledge graph of my application? Who is connected to what? Does my AI know about it? If it's not, I doubt that AI can figure it out the RCA for you, right? It has to know my A is connected to B is connected to C is connected to D, and how they are connected together. Until that does not come into picture, it's very hard. So The second, or I'll say, when the alert is fired, AI able to run simple queries, able to create knowledge graph, understand what component is connected to which component. It has that graph into picture that actually creates a foundation for your AI ops successfully getting adopted. If any of your AI initiative is not creating that knowledge graph and directly trying to jump into an RCA from an alert, I really doubt that will succeed or not. So alert got fired. Your AI app has to have your knowledge graph and need to have a capability of firing both simple queries as well as queries on multiple components together with the correlation. I think that's the next step your AI should be doing getting closer to an RCA.
Pretty interesting points. Love those points, and this is the kind of perspective I loved when you gave that talk at a meetup as well, Manoj. Thanks for sharing that. Rajat, what about you? You've been having a lot of conversations with companies, and you've been in the KubeCon as well, right? And because we've been building something around root cause analysis, so how you've been looking into this area, and where do you think that's AI can genuinely help in this entire flow of correlating between different events, and try to reduce that mean time to response of a root deriving to that root cause analysis.
Yeah, just to build up on what Manoj said. So I think when you look at certain production issues, if you disregard the simple, things, nodes going down or pods going, like easier things, if you put those away, we look at the issues that actually have a higher mean time to resolution are issues exactly like what Manoj talked about, where multiple different. Oof.
Is it me or Rajat's camera got stuck?
I think Raj camera got stuck. I think I'm not sure if he got disconnected or something. Maybe we can wait for a few seconds.
Rajat, are you able to hear us? Or right, I think there's some internet lag
No,
from his end.
yeah,
Yeah,
yeah. I think I got
we'll
dropped
just
off.
try adding him again on the stream.
Yep.
It's been an interesting conversation, Manoj, that we are having right now. There have been, because I've been recently, because my talk was also around in the recent meetup. Just to give everyone context, my talk was also around AI-driven observability, right, which is one subset of AIOps, if I may, right. And what Manoj covered in his particular talk was how to actually think about before you start implementing AI, what to think about, right. I think that is something which I'm trying my best with the questions that I'm asking, try to bring out that knowledge from Manoj's experience and from Rajat's experience, what to think about these different stages of an incident, right. So I'm having a lot of fun. And let me see if there are any questions in the chat. I don't see any though right now. Alrighty, I think Rajat is back. Let me add him to the stage. Rajat, able to hear us?
Yes, I am. I apologize. I just my computer crashed.
No worries. Please continue.
Small
So, so,
production.
so, so we need AI really. AI
Yeah,
to
We need.
understand why the computer crashed. What all those variables?
exactly the root cause analysis. I think it's probably too many open tabs. I don't need AI for that. I have so many tabs open on Chrome. Okay. Um, yeah, I mean, getting back to it, I think the ones that really increase the mean time to resolution are the type of issues that Manoj talked about, where a couple of microservices acts in a particular sequence that cause an issue. Could be a database deadlock, could be some way that actually challenges the rest of the system, that things grind to a halt or causes other issues, right? And also, another thing to keep in mind is when you get the alert, like Manoj said, you know, that could be the time that you know, your monitoring system started to notice the symptoms, but the actual root cause may have happened 5 minutes ago, 10 minutes ago, 20 minutes ago, and it has to slowly propagated over a period of time to get to this point. So again, tracing those are pretty hard, right?
And
um,
then memory leak is one of that example, right? Memory leak
exactly.
is not happening at a time and it started back in only 2 3 hours later.
Yes, and then in fact, some memory leaks can happen over a couple of hours and days. I
Yes.
remember this. You know, I was dealing with this particular clinic application where it's about 1,000 odd clinics across East Coast and West Coast, and like clockwork, when the West Coast comes online, that's when they start to those applications start to go out of memory, and then their standard procedure is just to restart, right? So there are things like that, that you know, like particular events, load events, could be a particular how microservices act together. All those things come to together to create these production issues. So understanding those patterns are important. And I think 10 years ago, maybe, I can't remember, I read this book called Release It from Michael Nygaard. um, you know, he talks about multiple production outages and incidents that actually really profoundly changed the way I looked at building systems. How a fault can propagate. It starts in
Mhm.
one location and eventually causes a system-wide outage. And one of those was with an airline where you know, someone was making purchases you know, in a particular kiosk, and that somehow had some issue. And this application is running on an app server. It started sucking out the threads. You know, slowly that got backlogged. Now, because there's pressure, and the others were functioning okay, but the system couldn't keep up, so that went offline. Now, because that went off, and something else went off, and it kept on propagating, right? So faults can propagate from one subsystem to another as well. So there are lots of potentially difficult to understand type of scenarios that happens in production. And you know, figuring out RCA for those are very difficult by just looking at a log here, a trace here, you know, an alert there, right? So for those kind of things, I think exactly what Manoj said. You know, the AI has to have a knowledge graph of what those interactions are, right? That's number one. Otherwise, without that, you can. And I think that's also the approach that we've taken. And then you have to look at those services individually, but also together, to understand what is the timeline looks like. Can you build an incident timeline based on these things? And you know, obviously you might not get everything right, but at least if you build even a partial timeline, the human SRE can fill in the gaps based on the experience, and then get to that root cause quicker. So building that incident timeline and understanding the connectivity through a knowledge graph of how all these interactions happen, and trying to correlate those different issues. And like you said, there's obviously a difference between you know, cause and effect, right? So sometimes, you know, two couple of events can happen at the same time or in and around the same time, but they are just a coincidence. They may or may not be the actual reason. So trying to figure out all of that, I think, yeah, those are the challenges that you face. And I think, I mean, that's those are some of the things that we are looking into, and the challenges that we are facing right now. It's arguably a very hard problem to look at, because no matter what we do, there's always a case that not just the AI, but even a human cannot look at. But I think where AI can particularly help is, it's humanly impossible to look at all the variables in a quick time span, and that's where AI can help. Like for example, that I mentioned about that issue that was lingering on for two weeks, partly because it's hard to reproduce, but also you know, the dashboard was looking at JVM memory, but was not looking at off heap memory. The actual memory leak was in the off heap. So because they were not, and you can't shove everything into a dashboard either. So I'm not faulting the people who build the dashboard. My point is that if some, like, you know, if we had an AI tool that actually looks at all the variables quicker, we could have got to that. And actually, those are the things that kind of influenced, you know, how I am trying to build what we're building right now. Because that's where the AI can help. Look at some of these variables as quickly as possible, that it's humanly impossible for an SRE to do. Present that information, and get some guidance also from the SREs, because they know their system, they know how it operates, right? And work hand in hand to narrow down the root cause. I think that's probably where I think. So to Kunal's point, we are not replacing everyone. In fact, there is more SRE needed, like Manoj said. The systems are getting more and more complicated. We need to just augment and help the people who are currently, doing this SRE work. So that's kind of like my philosophy around it. Sorry about the long-winding answer and the technical
Yes,
challenges.
I recalled one of those incidents, Kunal. I know we are already taken a lot of time, but just want to do that difference between causation and correlation, right? So
Yes.
really, really, really important to understand. So one of the incident which I recall now is that, of course, everybody is now developing on Kubernetes, right? And Kubernetes ports can go to any node. I mean, that's Kubernetes decides, right? Depending upon what the resource allocation of each pod is. So you cannot say, I mean, there's a way to put things together in the same node, but in general, it's a Kubernetes who schedules pods, right? So we do have one of the incident where we have a regular job which runs every hour, every couple of hours. And what happened is that job is really important. So what we have done is an HPA setup, pod autoscaler. So what happened is the pod get scaled to a second or three or four, and this pod was using a volume. So because it's using a volume and that volume is mounted on a single node, what we result is like, okay, all the scaled ports should get into the same node. So there is a affinity defined so that they are scaled to the node, and it's a priority ports. Now, what this is causing now is whenever a scale up happens, new port comes in, uh, Kubernetes sees a high priority and it has to schedule into the same node. It will actually trying to what you call evict a low priority node to another port, no port, a node. I mean, low priority port to another node. Now, when this job is running, and that parallel pod may be any service. It may be service A, service B, service C, depending upon, because there are a lot of restarts, scaling keep happening, scheduling can happen. So continue to see that randomly some microservice goes down whenever this job runs. So sometimes it's service A, sometimes it's service B, sometimes it's service C, and it's really difficult. I mean, it looks very obvious now that it's maybe because of this, but when it actually happening, it was really difficult to figure it out. And the real reason was that it was getting scheduled on the same node as of the scaled port, right? It's scheduled on the same node. I mean, we were not able to correlate anything. Logs are not saying anything. Metrics are not saying anything. Everything was fine. CPU was fine. Memory was fine. But then why the port is getting evicted? Until unless you actually try to correlate that scaling and eviction is actually at the same time. When this port is getting scaled, at the same time something is getting evicted. So this port scaling event and this eviction event is actually at the same time. Until unless you don't relate these two events together, it's very difficult. I just recall that event. I just wanted to just mention here that how why the just the correlation is not only the causation also matters, right? Sometimes two unrelated things can also cause each other just because underneath they are somehow connected at a different level altogether, two, three, four, or whatever the level. These two things are connected by the single node underneath. They are getting scheduled on the same node. Just wanted to just recall, so I thought I should mention this
No,
incident here.
I'm glad you mentioned. That's actually a very good example to sort of wrap things up, that explains, like, the what we were really talking about and why it's important to go to figure out how to correlate those things, right? So then I am glad you mentioned that. Thank you.
And when A tells about this, right, it looks very silly. It looks very obvious. It start looking very obvious, actually.
That definitely makes sense, and I think it loosely sort of connects to one of the aspect which you hear a lot of people talk about when we talk about AI. Is there's one small aspect which is trust, right? When an AI system is suggesting me some probable root cause, what makes that suggestion trustworthy for
Yeah.
the person who's looking at it? right? And this is like a whole rabbit hole that we can go on with right now. What makes an AI root cause trustworthy, but I think we can take it in a separate conversation given the time, right? But I quickly want to cover the last two areas which we have left in the whole DevOps cycle. I know we have been going for a while now, but this is a interesting conversation that we are having. Let's talk about, probably in my opinion, the most controversial part of this whole loop, which is auto remediation, right? Every engineer loves the idea of some things getting fixed by themselves, and it sounds good, right? But nobody wants a random bot to restart the wrong things at 3 a.m. In the night, right? And it affecting a critical service. So, and because of this reason, most teams still are doing the manual fixes for incidents that repeat more than often, right? Rajit, you mentioned about a scenario where they restart all of the services again. They know that this is going to happen, but they restart it again and again, right? So I think the real question is, and it's fair to discuss, it isn't about what should we automate. Should we automate XYZ or should we automate something else? It's what's safe to automate, when and how, right? So according to both of you, what types of remediations actually make sense to automate, and which ones should always stay in that human control, right? Because I think if we tackle this head on, like how auto remediation works in AI, that is a very simple question to ask, in my opinion. What actually makes sense to automate in the first place, and where do we need that AI control? Manoj, can you take it from here?
Yeah, I mean, auto remediation, very, very, I think, controversial thing. Most will not allow AI to actually do the remediation part. But yeah, again, I will categorize into two parts. One is your AI running your own runbooks. You have defined your runbooks. It's a approved runbook. Some SREs has created. AI is only deciding which runbook to execute. And the second part is AI is actually developing runbooks at the fly based upon his own understanding or its own understanding, its own finding. It's actually creating runbooks and running it. The first part is something where you should be starting off. I mean, that's the first thing, right? You have your runbooks. Those runbooks are verified by SRE engineers. They have no side effects, even if they got executed. For example, let's say if you have a particular stateless application running and there are multiple replicas already, restarting one replica, and if you have, of course, has a proper restarting strategy, so that means your new port should come up first before you actually kill the existing one. If all that things are in place, restarting a pod may or adding a pod may be a kind of a non-impacting runbook, right? So something which does not have a side effect, right? So if it's properly reviewed and if AI is running such runbooks, even if it's wrongly running, its impact is less. I think that's where you should be starting off there. Uh, then, of course, if there is like some confidence start coming that AI is actually running or categorizing your runbook correctly based upon an incident, it's actually, so you might be having 50 or 100 runbooks, right? And every time AI runs, you find out the accuracy, right? Every time it's able to find your correct runbook to execute. If that's something is, so that's your first step. That's get completed, and then you actually move to the second, where you want your AI to tweak your runbooks. It's not generating altogether, but tweaks. So I have a runbook to restart a pod or maybe restart a deployment. So can my AI can restart a demo set now? Because I have already have a deployment, but can it convert into a demo set? I have a restart of a process on a Red Hat Linux, but can it do the same thing on maybe on an AI or any other platform, right? So something of that is similar, but not exactly same. It can it say, okay, this runbook is correct, but you have to tweak it a little bit, and that's where the second step comes in. Up to that level, I think confidence is okay at start with. But the third, where you say AI should generate its own runbook, I will not have that trust yet. So I have to think there has to be a manual approval cycle in it. So AI is saying, okay, this is what you should be executing. And then, of course, somebody is actually approving it, it's correct or not. So I think that's the starting point. I don't think so. I will let my AI execute anything randomly. And the second thing, which is very important here, access to the AI, right? What are the accesses you are giving to the AI? AI might create something which has a side effect, but if AI does not have access to do that, your runbook will always fail, because AI does not have is not authorized to do that actually, right? So what kind of a tools or what kind of a access privileges you give it to the AI to actually run something, that also play a critical role to have a little more reliable remediation cycle. Okay, of course you don't want everything to be approved, at the same time you don't give the full control to the AI. So there has to be a balances where you say, okay, you can run my own run book because I have already verified. You can run some other run books which is an altered version of the existing run book, but if you are say completely new, you need an approval. And of course you control the authority to something which does not result into a crash or some disastrous things being done by AI.
That sounds fair, and I really relate to the last point that you mentioned, right? Which is what are the right set of permissions that you're giving the AI. You need to create that balance. You need the right set of authorization, right? So that it's doing what it's supposed to do and not beyond that, and not even less than that, right?
Yeah.
And this is something we covered in one of the previous episodes as well, where we had the field CTO of Solo.io, Christian Posta. They, Rajat, and they talked about authorization, authentication of AI agents. So I definitely link that in the comments right now if anyone wants to check out. But Rajat, any perspective you'd like to share for this particular one?
Very much in line with what Manoj is talking about. That's the position that we've taken with the product as well. So a couple of things. I think the first one is about, should you use AI to do remediation? I think that's an organizational decision based on their risk tolerance and stuff like that. And to what extent it should be doing. The second is, I'll talk about the security stuff up front, exactly what Manoj said. You need to have the guardrails in place so that uh, not just malicious, but accidentally someone don't write a run book that can cause some bad side effects, right? So you need to have those guardrails in play. Number two is about the audit trail for this. Like, what did doesn't matter if it's a human or an AI or an AI agent. We need to know who did what and at what time, right? So an audit trail to back this up, right? So if we have those kind of guardrails in place where access is like the roles and the privileges and access is sorted out, and there is an audit trail that can give the more confidence about what it has done and at what time it has done, and so that you can obviously keep improving if there are issues, right? So that visibility is important. And then I think once you have thought about those policies and you have those in place, I also think the great place to start is executing runbooks that are predefined by a human SRE, and that's exactly what we have done with the product. And that's important because the human SRE can verify the run book. They can actually test it manually if need be, right? So there is some responsibility on that person, and then that person creates it. And also you need to limit the access to people who can create the run books versus actually from the rest of the population, right? So arguably your experienced SREs have created that, they've tested that, so now we've given that to the AI agent. And then once that AI agent executes that, over a period of time, you can tweak it, adjust it, and stuff like that. Either the AI can suggest things, or the human can look at the results and the feedback and adjust it. But I'm also still not 100% sure whether AI can generate things on the fly. Maybe it will to a certain point at later on. But I think we need to learn more about this problem and build better confidence about how it is doing, right? Also, one other aspect, I think Manoj and I talked about this before in an offline conversation. It's mostly to do with predictability and deterministic behavior, right? With Gen AI, the problem is it's not deterministic, right? You can ask the same question, it'll like 5 times, it'll give slightly 5 different answers, and so those are also going to be factored into this equation, because when you're solving something, you need to solve it in a repeatable fashion, right? I mean, that's we talk about that's the very definition of a run book. So those things have to be taken into account as well.
Very interesting points. Yeah, thank you both for sharing your perspective. I know we've been going for a long while now, and thank you so much, both of you, for bearing with me. We have around like 12 people right now watching till since the start. So I just want to say thank you for bearing with us. Right, we're just at the end of this particular discussion, but I just to close that whole loop, right, of AI ops that we have been discussing. The last and one of the major stages that comes is the feedback loop, which we talk about, right? Everyone says that, hey, I'm implementing AI and I expect it to learn from every incident, but in practice, how does that engineer actually close the loop? How does that engineer actually give the feedback? And this is a question I recently created about a post about this as well on my account, that what are the ways in which we can practically see an engineer giving feedback to an AI system in production, right? So practically speaking, right, how do you think, what are the top, let's say, two or three ways, according to all of you, how do you think teams can actually close that feedback loop and give feedback to whatever the AI is doing so that it can improve with the next incidents, right? And I think that is one of the critical stages which can make or break all of this, right? So Manoj, do you have anything perspective to share in this?
Sure. I think first I like just to talk about again, Ajit, the Gen AI part, what Rich was saying, right? It can give you 5 or 10 different answers if you ask something. And that's where I think, Kunal, we had a discussion, right? That the AI need to be opinionated. It cannot be just say random. I mean, AI is giving me something, okay, some answer, and I say, no, you are wrong. It will accept, yeah, I am wrong. Let me give you a second answer, right? So that, that happens with Gen AI, right? Maybe because it's not backed by facts, it's not backed by a knowledge graph. When you start using a causal graph or a causal AI, not the Gen AI, causal AI does not, because causal AI has some kind of a graph with it, some kind of a factual data with it, which says, okay, when these three things comes together, this happens, right? So your causal AI gives you the inference, and your Gen AI actually expand it to explain it in a normal English. That's how the AI should be working. You are not going to believe on Gen AI to actually find the RCA. Your RCA has to be found by some causal graph or some causal inference techniques actually. But yeah, that's on Rajit. But now question, what you asked is the feedback loop. That's really important, and that's actually has a lot bigger impact. I don't know if the possibility of closing that feedback loop with the current set of techniques and observability tools which we are using. Uh, when it comes to feedback loop within the same session, of course, that's very easy because most of the chat system, right, they use your context. Whatever you have said in the past, right, they actually take that into his own context window and make use of it in the next response. It's really easy. You say if you are wrong, it will say, yes, I am wrong. It will take that you are wrong statement in the context, and next time it's not going to tell you the same thing. It will come up with something else. Or if you are say, okay, your five statement is right, but six doesn't make sense to me, it will actually take that input and it actually try to revise. So in the same context window, yes, feedback is possible. But when it comes to a persistent thing, right, that in future it does not happen, the whole of this context has to go to its training set, right? The whatever the AI model which we are using, right, this training set should make use of that to train it again. Now, is it possible? Maybe because if you are hosting your own model, but that's not the case recently, right? So most of the vendor host models which are actually trained for different industries, right? If your e-commerce site, your manufacturing site, you might be running something else on your portal, you might be running some training, whatever. I mean, there may be different industries which are using the things, right? And when a SaaS observability platform is trying to give you that, it need to cater to all its customers. I don't know if they deploy different models for different type of industries. I don't know. Do they take our feedback, whatever we are talking, as an input and train them? I don't know. So yeah, I mean, contextually it's possible. If you really want to close the loop, it's better to get more control on your model. Maybe have some kind of a foundational model with you, which is already has some SRE based training done, and then maybe you just retrain them based upon your own local inputs and refresh it. So that may be, but I don't know if it's possible to actually have that, considering the cost, considering the infra requirement to actually host your own model there.
Interesting. Rajat, how have you been thinking in this direction? Because this is, as I mentioned, right? This is a, as also Manoj mentioned, this is a pretty major stage, because we're at the end of this, right? This is something that which might break or make things in the next incident. So how have you been thinking in this direction?
Not very different from what Manoj already mentioned, right? Like Gen AI is already good at consider, like, taking the your previous inputs when it suggests the next couple of steps, right? So within the same context window, there's that natural feedback loop that's already there, right? But the larger problem is, how can you learn from incidents? How can you learn from some of the things that you've done? But you run into practical challenges, exactly what Manoj mentioned. Are you going to run a model per customer, because every customer is different, right? Are you going to build a very, like, forget about even every customer, right? Like, if you take the current models out there, they're trained on a wide variety of things. It can tell me the weather, it can plan my travel, but it can also answer my SRE stuff, right? So are we, I think in the future we are going to see models that are trained exactly, if not, I think some of the larger vendors are already probably working on it, SRE specific models, right? That are, could be a small language model kind of thing, right? And there's also like what Manoj mentioned, there is also the traditional ML models that you can use for inferencing, that actually can be highly trained for the situation at hand. But even then, though, every customer is different. How anomaly may work for one customer might be different from another customer because of different patterns and stuff. So there's a challenge. I think there's a when it comes to practicality and other things, and cost, when it comes to building the feedback loop. But there are other things that you could potentially do that can perhaps improve the feedback loop. So one is, when the SREs and stuff like that provide these run books, people can provide feedback saying, this was useful, this was not. So they can adjust that, and perhaps that input can be taken by the LLM, not LLM, I mean by the AI agent, to kind of suggest improvements to it. So not really big things, but minor things, like based on how it performed, providing that feedback loop to your own organization, and then improving your run books. Also, the relevance of the run books, right? Because if you're like, the idea is you provide the run books, and some intelligent capability is matching those run books, and you can influence that algorithm a little bit. Also, capturing feedback from that incident, and perhaps putting that into context, because maybe if you're analyzing past incidents, that knowledge can be now used to analyze the next. So you can work around some of those challenges that we talked about in sort of other ways, because trying to find that more holistic sort of approach, I think we're still a while away because of cost and other sort of challenges and practicality challenges. So yeah, that's kind of like my opinion about how to deal with the feedback loop, in using a couple more creative ways. But I think we're still a while away, like Manoj said.
And
From
I think that's a great point, Ajit. I think uh, you may not need a model per customer, but you can always need a memory per customer. So
correct.
you keep a summarized feedback memory per customer, and when your agent know that whom he is talking to, it actually pick up that memory, summary memory, and start putting into the context. I don't know how much it's possible, but yeah, AI can summarize, right? It can always summarize your previous
Incident.
discussions and all that stuff, and you keep that summary into some kind of a memory. And I'm sure the RAG kind of stuff can also happen, right? Where summarized version has been put into your RAG model, and you can actually take it from the RAG. Yes, that's maybe one of the approach for the feedback loop which can be used.
Love those points. And I think one thing definitely is clear to me, that there is no one concrete answer to it right now, at least right now, right? We are still exploring possibilities, we are still trying to see, how these can be implemented. But I think these back and forth is something which is needed, right, to have that kind of one or two concrete things that teams can actually do in production, right? But with this, we are at the end of this particular episode. I just want to thank from the bottom of my heart, thank you so much, Rajat and Manoj, for bearing with us for, like, I think more than an hour now, close to, I think, 1.5 hours. This has been a crazy ride, but I think this is a really good valuable episode that we have created right now. It's sort of a one-on-one, I would say, on AI ops. I know there are a lot of different areas that we weren't able to cover, right? AI summarizing the visualizations is another part of it, right? We weren't able to discuss about that trust part of AI, right? How can we trust? What are the certain responses? How can we, make the AI more trustworthy? I think, Manoj, we'd love to have you in another episode as well, in
Sure,
the future,
sure.
to talk about these particular aspects. But again, thank you so much, everyone, for staying with us for so long. I hope this is valuable for all. If you haven't got any questions, I'm really sorry we weren't able to answer it, but you can definitely reach out to me, Rajat, or Manoj. I'll link to their social handles in the description below, so you can reach out to them. You can connect with them on LinkedIn and on socials, and you can, always feel free to reach out to them for any questions and any discussions you may have. With that being said, thank you so much for everyone for joining, and thanks again, Rajat and Manoj, for staying with us for so
Thanks.
long. I hope you all had fun. We'll see you in the next one.
Sure, sure. Thank you. Thank you so much, Kunal. Bye bye.
Thank you
Bye
very
bye.
much, Manoj. Really appreciate it. Great conversation. Take care. Thank you.
Yeah, bye bye.
Bye bye.